Okay guys, so today I wanted to show you a visual diagram of how the seasons occur, adjusted to our revolution and our rotation of our planet. So you'll notice that it's pretty dark where I am right now. It's because I wanted you to be able to see this light. So assume that this melon right here is the sun, and this earth right, and this orange right here is the earth, okay? So I drew a line right at the center of the orange, right in between both of its little pit sides. Okay, this line represents the equator, but as you guys know, the planet doesn't rotate like this. It rotates on a tilt. So depending on where you're looking at, it's on a 23-degree tilt. So that'd be 90 degrees. So we're looking at something like, that'd be 45 degrees, something like right here. Okay, so that guy's gonna go around. So it's gonna rotate on a fixed axis, and it's gonna go around. It's gonna revolve around the sun. So let's check it out. So pay attention to this light. Okay, so let's start. Okay, so remember, when we're looking at the Earth from the North Pole, so let's assume that this is the North Pole. Okay, the Earth's always gonna be going counterclockwise. Counterclockwise. Okay, so let's start from what we would call a southern hemisphere summer. So let's put it on its tilt, and remember, counterclockwise. So let's say that this is Argentina, South Africa, Australia. Check it out. And let's rotate it. Daytime in Australia, summer daytime in Australia, summer nighttime in Argentina, summer nighttime in Argentina, summer daytime in Australia. So the days change. So over here on the other side of the orange in the southern hemisphere, it's still summer, but it's nighttime. And when we rotate it, daytime on the other side of the planet. But the seasons come from its position during the revolution. So let's look at the other side. So remember, we're keeping this fixed rotation in space. Spring, summer for us. So let's turn this light on, see what happens. So let's say that that's New York City, daytime. China, daytime, all summer. The direct sunlight, because of the Earth's tilt, is determining the season. So the whole northern hemisphere right now, because of the Earth's tilt, is experiencing the most direct solar radiation, while everything down here on the other side is experiencing a lot less. It's still getting it. That's their winter. Okay, just like from over here. Summertime for the southern hemisphere, Earth's rotating, but we're still getting solar radiation in China and America and Europe. But the thing is, we're just not getting quite as much. The days come up and the nights come up, so the nights and the days come from the rotation. Okay, so there's your spring. You can't really see it right now, but it's a perfectly equal amount. So we're probably something like right here, right now. Okay, we're in like mid-April. Okay, we just passed the spring and we're cruising into summer. The days are getting a lot hotter. This is how it would look for fall. See? Pretty equal amount of solar radiation on both hemispheres of the planet at this point in time. So remember, it's all because of the tilt. The 23-degree tilt never changes as it goes around the planet. So just to give you a quick snapshot again, that fixed tilt, northern hemisphere. Remember, I'm not going like this now. Fixed tilt. Summertime in the southern hemisphere, fixed tilt. Thanks guys.